For this verification, I'm going to go left to right, and I'm going to turn all of the tangents and cotangents into sines over cosines or cosines over sines. And then what we can do is we can drop a 1 here, and we can get a common denominator here in the bottom by multiplying top and bottom by sine x. And here, similarly, cosine x top and bottom. So let's see what this gives us. And now let's do that thing where instead of dividing fractions, we'll multiply by the reciprocal of the bottom. And we'll do that for both situations. Okay, now here we have sine squared over this plus cosine squared over this. So now I have two fractions, but the denominators are not the same. For instance, this is cosine and this is sine. So what is this going to need, top and bottom? Well, this is going to need, see, this is sine and this is cosine. So I think that this is going to need an additional sine, and I think this is going to need an additional cosine. But that's not enough, because look, this is going to be sine, cosine, sine, cosine. That's good. But the parentheses are not the same. This is sine minus cosine. This is cosine minus sine. That's not the same thing, bro. So here's what we can do. Instead of cosine minus sine, I'm going to call this sine minus cosine. But if I switch the order of the subtraction, you have to put a negative in the front somewhere. We've seen that trick before. Remember that? Where if you switch the order of a subtraction, do it, but put a negative like in the front or maybe to the top somewhere. There has to be a negative placed somewhere. So let's clean this up. So now we can combine the two fractions into one. So this is what we have right now. So while I erase this board, let me just talk a little bit more. I want to remind you of a difference of cubes. Do you remember how to factorize a difference of cubes? So for instance, the general idea is this. If you have a to the power of 3 minus b to the power of 3, that has the following factorization, okay? It's based on a pattern. So this would look like a minus b times a squared plus ab plus b squared. This is one of those concepts from like Math 1 or Math 2 back in the day. It's called a difference of cubes. I want to do that in the numerator. If you look at our numerator, sine cubed minus cosine cubed, it looks just like this. So let's factorize the numerator using this idea. Sine minus cosine times sine squared plus sine cosine plus cosine squared, close that parenthesis. All of this gibberish above sine, cosine, and then the parentheses. Okay. Now, let me take a step back and ask you if you notice anything. I notice something. I notice that this knocks out with this. I also notice that this combination of blue, sine squared plus cosine squared, that is 1. So I have 1 plus sine cosine over sine cosine. So now what I want to do is I want to break this up into this fraction here plus this fraction here. If I rip it apart into two fractions, it's 1 over sine cosine plus sine cosine above sine cosine. And here, this can come to the top, and this can come to the top. This would become cosecant, this would become secant, and this is just 1. So I have 1 plus secant x cosecant x, which is the desired result.